Hey everyone, welcome to this video. In this video, I'm gonna solve Koko eating bananas problem 875 on LeetCode. It's a medium problem and it's not that difficult. It's just that you need to have proper logic to do this one. I'm gonna use binary search for solving this problem. So let's first visualize what the problem is trying to say and then we'll understand our algorithm.
Yeah, folks. So, for example, if we are given three piles of bananas, each containing 6, 8, and 2 bananas respectively, right? And we are given amount of time in hours. For example, we are given 4 hours. So, what we have to do here is we have to allow Koko to eat all these bananas before this time collapses in less than equal to 4 hours, right? And the condition given to us is that okay, we have to assign Koko an eating speed of bananas per hour, right? Bananas per hour. So if I allow Koko to eat, for example, 6 bananas per hour, okay, so in that case what will happen? Koko can eat all the 6 bananas of this pile and it will take her 1 hour, fine. But when Koko comes to the second pile, we have 8 bananas here. So Koko will eat the first 6 bananas in 1 hour. Okay, that's fine. But then we still have 2 bananas remaining. For those 2 bananas, Koko will again take 1 extra hour, 1 complete hour. It will not be like you will divide the time and she will take the time in minutes. No, Koko likes to eat slowly and enjoys her eating. Therefore, she will only finish one pile in the given amount of time, right? And similarly, if there are 2 bananas in the third pile, so Koko will not leave the time, as in she will take the whole 1 hour to finish this pile. So for example, if we had one more pile here, if we had one more pile here, if we have 4 bananas, one more pile here, right? So now you will not say that Koko will finish these 2 bananas and these 4 bananas as well in the 1 hour. No, she will take 1 complete hour for this pile and another hour for this pile, right? So now let's understand with the LeetCode problem. The problem says that we are given 4 piles, each containing 3, 6, 7, and 11 bananas, and we are given 8 hours. So we have to find a solution in which Koko is able to finish all the bananas in less than equal to 8 hours. Okay, so we are using binary search in this code. So let's see. For binary search, we need a range. Fine. For the range, we need a start pointer and an end pointer. So think deeply. And if you think deeply, you will see that you have to allow Koko the maximum number of bananas, the pile which has maximum number of bananas, that has to be your end pointer. Why? Because think of a case in which you are given only 4 hours, right? In a case, if you are given only the hours equal to the number of piles, in this case if h is equal to 8, then to finish all these bananas, you will have to finish one pile in 1 hour, right? And in order to do so, you will have to allow Koko to eat the maximum number of bananas in 1 hour. Therefore, you have to assign the end pointer equal to the maximum number in the array. Fine. And the minimum amount of bananas you can allow her to eat can be equal to 1. 1 is just a random number. You cannot, because you cannot give her 0, because if you give her 0 bananas to eat, then she will not finish the bananas if you give her n number of hours. Therefore, you have to start from 1. So our range is 1 to 11 for the first test. So our middle is here 6. Fine. So let's dry run and check. Okay. So the first pile contains 3 bananas. 3 is less than 6. Yes. So Koko will finish the first pile in 1 hour. This first pile takes 1 hour. Second pile. The second pile has 6 bananas. 6 is equal to 6, right? So again, Koko can finish this whole pile in just a single hour. So far so good. Now the third pile has 7 bananas. So in this pile what will happen is 7 minus 6. These 6 bananas will be eaten in 1 hour, and the remaining 1 banana will take 1 extra hour, 1 extra whole hour to complete. Therefore she will take 2 hours for this third pile. And similarly in the fourth pile, where we have 11 bananas, 11 minus 6 equal to 5. Therefore she will take 1 hour for these 6 bananas and another hour for these 5 bananas. So 2 hours here as well. Let's add these hours. 2 plus 2, 4, 5, 6. Now 6 is less than 8. This is our given amount of time. So yes, this is a potential answer. 6 can be our answer. But our whole purpose is to let Koko eat as slowly as possible. We don't want to rush her. So okay, 6 is a potential answer, but we have to look for more number of answers, lesser number of answers. We have to look for answers smaller than 6, right? So now that I have found a potential answer, I'll move my end pointer to mid minus 1. That is 6 minus 1, 5. Why? Because I have to find a smaller answer as well. I have to look for a smaller answer as well. Therefore, now my new range, let me clean this. Now my new range becomes 1 to 5. My start pointer is 1, my end pointer is 5. Right? Now the middle is 3. 5 plus 1, 6 by 2, 3. The middle is 3. Now let's check for 3 if we can finish all the bananas in the given amount of time. Let's check that. Okay. Right. So we can finish the first pile in 1 hour. Fine, because 3 is equal to 3. Fine, we can do that. Is 6 less than 3? No, it's not. Therefore 6 minus 3. These 3 bananas will take 1 hour, and the remaining 3 bananas will also take 1 hour. Therefore she will take 2 hours to complete the second pile. For the third pile we have 7 bananas. So 7 minus 3. Koko will take 1 hour for these 3 bananas. Then we have 4 bananas remaining. So 4 minus 3. Again we have 1 banana remaining. So therefore for the remaining last banana also Koko will take 1 hour. So in total, to finish these 7 bananas, Koko will take 3 hours. Right? And similarly for 11 bananas, what Koko will do is 11 minus 3, that is 8. 8 minus 3, that is 5. 5 minus 3, that is 2. Right? And now 3 is less than 2. So now we can stop subtracting, and now 1, 2, 3, 4. Koko will take 4 hours to complete these 11 bananas. So let's add them. 7, 8, 9 and 10. So now my hours become 10, which is greater than 8. Therefore the guards will arrive and she will not be able to finish all the bananas. So therefore 3 is not the answer. So I have to look for bigger numbers now. As I have to look for bigger numbers, therefore I'll move my start pointer to mid plus 1. Yes, I'll move my start pointer to mid plus 1. So now what happens is my start becomes 4 and my end is 5. So let's clean this a bit now. Yes. So now my start pointer is 4 and my end pointer is 5. So the mid is 4 here. Fine, 9 by 2, 8. That's my, 9 by 2, 4. That's my mid here. Fine. Now let's check if I can allow Koko to eat 4 bananas per hour. Let's see. The first pile has 3 bananas. 3 is less than equal to 4. Yes. So Koko can eat this whole pile in 1 hour. Fine. The second pile has 6 bananas. 6 minus 4. Okay. 2 bananas remain. 2 is less than 4. So again 1 hour. Therefore Koko will take 2 more hours for the second pile. The third pile has 7 bananas. So 7 minus 4 will take 1 hour. Right? And the remaining 3 bananas will also take 1 hour. Right? So again these can be finished in 2 hours. Similarly, the last pile has 11 bananas. So 11 minus 4 will take 1 hour. We have 7 remaining. 7 minus 4 will take 1 hour. We have 3 remaining. 3 will take 1 hour. So 3 hours for the last pile. Now let's add them. 3 plus 2 5 plus 2 7 plus 1 8. So the hours are equal to 8. Therefore I can finish. Therefore Koko can finish eating all the bananas in the given time if I allow Koko to eat 4 bananas per hour. Therefore 4 is again a potential answer. So now, as I have found a potential answer, what I will do, folks? I will bring my end pointer to mid minus 1. Right? Now my mid is 4, my end is 5. So what will happen here? What will happen here? End will come at 3, my start is at 4. Right? So now this is my break condition. As start has become greater than, as end has become less than start, as my end pointer has become less than start, this is a break condition, and therefore I return my start as my start is containing the answer. Okay folks, so this was the algorithm and I hope you are very much clear with it as I gave a very thorough explanation. So I suggest you go ahead and code it, but no issues. If you lag behind, you can anyways come back and later and watch the code for any issues you face.
Yeah, folks. So what I'll do here is I'll create first of all the start equal to 1, and I'll initialize my end equal to arrays dot stream piles dot max dot get as int. This is a library function to get the maximum among the arrays, to get the maximum element in the array, sorry, right? And here's a simple binary search while loop. While start is less than equal to end, what I will do is I will int mid is equal to start plus end minus start by 2, right? And then if can eat, this is a function that I'll create later on. If can eat in time, if can eat, okay, this is the function I create later on. If can eat, here I'll pass piles, my mid, and the number of hours. If can eat, then what we have to do is we have to bring our end to mid minus 1. Why? Because we have found a potential answer. If Koko can finish, if Koko can eat in time, then we bring our end to mid minus 1. Else, what we'll do is we'll take our start to mid plus 1. This is very simple. I've explained it very clearly. You get why I'm doing this, and then I'll run start as my start has the answer. This is very much clear to you folks, right? Now I'll make the function can eat, private boolean can eat. Here I have to call the array piles. This is the eating speed k and int h, right? Now I'll initialize my hours to 0 first of all, right? As my hours have to be 0 while starting, right? And then a simple for each loop. For each pile in the piles array, what I have to do is I have to divide my number of bananas with the speed, right? For example, if we have 6 bananas, I have to divide 6 by 4. If my k is equal to 4, if my mid is equal to 4, then I will divide 6 with 4. Therefore, I get 1 as the quotient, right? So 1 is the answer. My r's become equal to div. This much is clear. So pile divide by k. Why? Because I have to divide 6 by 4, right? And my hours are gonna be added to div, right? Makes sense? Now, if my piles has a remainder, if after dividing I have a remainder, I have, if after dividing I have a remainder, When will I have a remainder? I will only have a remainder when the remaining number of bananas is less than middle value, is less than mid, is less than k, right? In that case, we know that Koko can finish all bananas in the 1 hour. Why? Because that remaining number is less than equal to mid, is less than equal to k, is less than equal to the eating speed, right? So for that number of bananas, we can give her 1 extra hour to finish. Fine. And we have to now return our, we have to return only if our, we have to return true if our hours are less than equal to h, right? So let's run this code and see if it actually works. It has an error. Why it has an, oh, for int I forgot to initialize. Now let's check. Yep, it works. Fine. So that's it for this video. I hope you got something out of it. And if you liked it, please press the like button and subscribe to my channel for further updates and further such videos. Also share these videos with your friends whom you find it helpful, as learning together is the motto of this channel, of this community. Okay folks, bye bye, take care, see you, have a good day.